guess this will be part 14. Just sort of a bit of a mini update really. This is the board that's going to go up in the ceiling, and I did say to you the other week that I was going to change this main board. Here had voltage regulators on it. It had a 5-volt regulator and it had a variable regulator. This is when I sort of first started this and it seemed the way to go. So I was going to supply it with, like, initially I was putting 9 volts into it on this board down here somewhere. There was a connector and I was putting 9 volts into it. It was then getting fed through the 5-volt regulator, and the power was getting pulled off for the Mega 2560 and the Nanos, and I was taking 7.5 volts or 9 volts over to this board. But the regulators on these things, little regulator here, they get so bloody hot. That's all Arduinos. It's not just the clone. They all get really hot. So, you know, I don't know. I'm guessing that's going to fail after time. So that was with 9 volts in it. I then dropped it to 7.5 volts because when I've got all the exhausts on and all the other LEDs and, you know, everything's running, this was getting hot because current's quite high. Obviously you're stepping down from, you know, 9 volts down to basically 5, so you're losing a lot of heat. So I put it into 7.5 volt, put 7.5 volts in. This was much cooler. This heatsink on here was also cooler, but still quite warm. And I thought, well, really, if I'm going to do that, I may as well go over and get myself a 5-volt power supply. So I've got myself one of these. I think it's an EPS. I can't remember the exact model. It's 15 watt, which is like 3.3 amps. So you've got mains in one side and 5 volts out the other. I haven't connected them because these connectors are not the same as the other connectors I'm using, which means I've got to order them, and you can't just buy one of each. You know, it's just not really that cost effective. So I sort of like fed the mains in now, so that I've got one plug on this at the moment with it, which is going to be the mains in, and that goes into like my distribution block here. I then feed out to this 12-volt transformer, which just all that does is run the fans. So at the moment I've taken it, that's my 12 volts in and my 12 volts straight out to the model. I could run the 12 volts out of this fan, out of this relay here. There's not really any major gain to me to do that, to be honest. Other than I can control when the fans come on, but I want the fans on all the time anyway, so there's not a massive gain to me. I've had a go at tidying it up a little bit because obviously I had to take this board out, and I've kind of cable tied it all to keep it, because there are a lot of them are flat cables. You know, I don't want to just crunch them right up into a ball. There's a few left out here because this one is the internal temp sensor. I'm going to mount that on a post somewhere up here. I don't know where I'm going to put it. I'm going to just put it on a post somewhere. You know, one of the 10mm, you know, like mount it on a post so that it's attached. The other one is, where's the other one at? The other one is an LDR, which is around here somewhere in this pile. I can't find it at the moment. I will find it. There's a light dependent resistor, which again is going to get either drilled through the wood, or I don't know what Dean's going to do underneath it, so I've kind of left it. Oh, here it is. So that's the LDR. I've just poked that through, and that senses the light in the room and will set the model lights accordingly, which I can change that in code. I've got excuse me, I'm still feeding the power for the display directly from the Mega. That's the 5 volts and 0 volts. I've got the serial data, which is these ones. So this is like from my serial port from the Mega, so I can talk to the display and read back from the display, so it's two-way traffic on that. I've then connected this little board here, which is because this is the enhanced Nextion display, so you get the GPIO pins on it. So funnily enough, actually, this board here, this might be worth a note if you're going to do one of these yourself. This little board here was a couple of quid. It was off eBay, But what they've done, that when they've done the stenciling on this, the stenciling's the wrong way round. So it's like that stenciling should have been on the other side of the board, and it would be the rotten. Do you know what I mean? It'd be like reversed. It's because I spent ages trying to find out why it wasn't working. And when they say pin 1, it's not pin 1, and 0 volts isn't 0 volts. You know, it's 5 volts. So it took me a while to work that out because it just didn't work. But what I do, I run a title sequence on here. And once the title sequence is finished, so that way I can add more jokes and I can make this title song longer and things like that without having to. And I know that like, the rest of this won't start doing what it's supposed to do until the display says I finished, because all the screenshots and the titles are loaded on an SD card, and they're actually loaded onto resident on the board here. I don't send them down the serial cable, it takes forever. So once it's finished, I then set this pin high. You know, I just do an interrupt on that on the Mega. There's an interrupt pin, and I just read that, so I know when the display is finished. So I can add things to the front. I can make it take longer to start. Also, if this fails to start, it will stop the whole thing running. That could be a problem, I guess. If something's gone wrong with it, it means I need to fix it immediately, but I probably would anyway. But a simple code change will stop that happening, so that it doesn't wait for this interrupt. It just carries on. So once the program runs on here, it waits for the interrupt from the display. So everything's waiting for the display to finish, then all the engines start up on the model. What I'll do now, I've got a cough here. I'll just turn it on. Right, so I'll turn this on now. So here we are. So this starts up. At the moment there's no title sequence, so it just slips straight through it. And that's it, switch the lights on. So the fans are on first and the lights come on. I can change the order of all this in software anyway. But then the next part that I need to do now is, I've got a tea strainer here somewhere. I don't know where I put it. I had one I took apart the other day and I can't find that. I put that in a safe place. But we've basically got a tea strainer because it's like nice and oval, and it's going to fit in here. On the other model, we put it in the top, didn't we? And I glued it all in beforehand and then shut it. But the problem we got with this one is because we put it in the middle, which looks better, but obviously I can only glue one half of it. Do you know what I mean? I can't. Oh, okay. Well, if I glued it, I'd never get it apart, and I'd destroy the mesh getting it out. Right. Well, there's several hours passed since the last time I videoed this, where I'd like altered this. Some of these I'd pulled out, I think. So I wasted hours looking at this sort of stuff. Then there was a problem with a broken wire between this pin here and that pin there, and that's taken me, because I was testing it 1 minute and it's fine, and then testing it, and when you sort of take it apart and test it, it was working, but when you put it back together, it wasn't switching the LEDs on. That click wasn't happening. The only way I could do it was to put that jumper on and get it to work. It's just been an absolute nightmare. It's because I've had this board out and removed all these the regulators and stuff. It has just been a nightmare getting it all back. There's just wires loose. I mean, you know, they're all, I've stripped these and soldered them. They're crimped with the proper crimping tool and everything. I got that. So there's no reason why I should have had so much aggro with it, but my goodness me, I've literally spent all morning on this. I don't know what the time is now, but it's got to be, what is it, 1 o'clock, and I've spent all day on it, and it's just literally going over and over and over and testing this thing so that it starts, because, you know, I don't want this going up in the ceiling and then there's a problem with it, you know. Anyway, I think that is me done with it now. I think it's back to how it was. What I was actually going to show you, I'll put back on again now. I fitted a diffuser into the exhaust, so we'll try that and see what that looks like. Here I will show you the diffusers. So I fitted one in the top left here. I've just got that one on the top. It's not as bright in real life as it is in the video. It's not, you know, it doesn't look so sharp, but it looks, I think it looks fine. And I've also got it so that you can still see the bleed through on the exhaust sort of like cowlings, if you like. It bleeds through the plastic, which we wanted to keep that. So I've pushed the diffuser only in about 3 or 4 mil in there and glued it in. So the effect is the good from the side, and looking directly at it, you know, it's when it's fully on. I mean, these are quite bright because the room's dark, but that's it switched over to like run in there now, and this is straight on at it. So when you're looking right at the LEDs, it's like really, really bright when you're right at it, whereas it's better through the diffuser. But I'll leave it to Dean, see what he thinks. But anyway, that's it. Little update for a Sunday. Thanks very much for watching, and I shall catch you on the next one. Thank you. Bye-bye.